Okay, so what we want to do here is find the critical points of f of x equals x minus 1 squared plus 2, and determine if they're a local max or a local min using the first derivative test. So when we ask for the critical points of a function, what we're asking for is where does the derivative equal 0? So let's take the derivative. So the derivative of x minus 1 squared plus 2, well, for the first part, we'll have x2 times x minus 1 to the first power times the derivative of the inside plus 0, because the derivative of a constant is 0, so the derivative of 2 is 0. So we'll have 2 times x minus 1. Now the derivative of x is 1, the derivative of negative 1 is 0, so this is just times 1. So the derivative, f prime of x, is 2 times x minus 1, which is 2x minus 2. So to find the critical points, we're asking for f prime of x equals 0. So that would mean 2x equals 2, which means x is 1. So this is our critical point. Now, just having the critical point is not all the information we could get from this. We could also tell if it's a local max or a local min using the first derivative test. So what does the first derivative test say? Well, if we look at a couple of graphs, let's look at this graph and this graph. So if we notice here, the derivative, the slope of the tangent line, goes from being a positive slope to a negative slope. So if we go from positive to negative, we have a local max. If we go from having negative slopes to positive slopes, we have a local minimum. So, well, all we need to do is we need to test the derivative on either side of our critical point and see if it goes from a positive to a negative or negative to a positive. So let's do that. Let's plot some points on a number line. So this is our critical point, x equals 1, and let's take points on either side. So let's say x equals 2 and x equals 0. Nice and easy. So f prime of 0 is 2 times 0 minus 2, which is negative 2. So over here, we have negative values. F prime of 2 is 2 times 2 minus 2, which is 4 minus 2, which is 2. So over here, we have positive values. So since we go from negative to positive, we have a local minimum. So by the first derivative test, f of x attains a local minimum at x equals 1. Now to see that graphically, let's actually graph this function. So we have f of x is equal to x minus 1 squared plus 2. So this tells us we shift the parent function x squared to the right one and up 2. So we would have our standard parabola, just shifted slightly. And if we notice, there is in fact a local minimum at x equals 1.